9. Now you will have to make the state table, transition table for this. So let's make a transition table, or the parsing table, not the transition table, but the parsing table. And for this parsing table we have the states. You can see that the number of a state here are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we are making the states 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The two parts in this parsing table, one part is action, the other part is go to. In action we will have all the terminal symbols. So in this case the terminal symbols are A, B and $. In the go to part we have capital S and capital A. Now let's make entries to this table according to this canonical collection of the items. So if you see that from 0 state with capital S we are going to 1. So 0 with capital S we are going to 1. 0 with capital A we are going to 2. So 0 with capital A we are going to 2. And then 0 to small a you are going to 3 state. 0 to small a you are going to 3 state. So S3. 0 to B 4 state. So you will be writing S4 here. Now see the transition from 1. From 1 if I shift a $, it actually is like we have reduced the string to the start symbol, and a $, appears after that. It means with 1 and $, we are going to accept. With 2 and capital A, you can now see that with 2 and on capital A, with 2 on capital A, you're going to state number 5. 2 on capital A, you're going to state number 5. On 2 with the small a, you're going to 6 state. 2 with the small a, S6. 2 with the small b, 7, it means S7. 3 with capital A, you're going to 8. 3 with capital A, you're going to 8. 3 with the small a, you're going to remain in the same state. So 3 with the small a, S3. 3 with the small b, 4 state, S4. No transition from 4. No transition from 5. And then from 6. From 6 on capital A, you're going to 9. From 6 on capital A, you're going to 9. From 6 on small a, you're remaining in the same state as 6. From 6 to small a, S6. From 6 to small b, you are going to remain in 7 state. You're going to in the 7 state, so S7. And then from 8, there is no transition. From 9, there is no transition. Okay. Now the part of the reductions. Now you will have to find out what are the final items. What are the states that those are producing the final items. So 4 state, state number 5. State number 7, state number 8 and state number 9. So starting from the state number 4, this is A produces B dot, and if we number these productions 1, 2 and 3, so in the 4th line or the 4th row in the parsing table, you will be writing R3, but you will be writing the R3 only at the places A and B. Okay, so whatever are the look aheads, you will be writing the reductions in those places only. So A produces B dot, small a, small b. This is the 3rd production, so you'll be writing R3 in the 4th row. So R3 in the 4th row at the places A and B. So at the places A and B, you'll be writing R3 and R3. Now go to the 5th state, which is the production number 1. So you'll be writing R1 in the 5th row of the table, but only at the place $. So only at the place $, in the 5th row, you'll be writing R1. The state number 7. State number 7 is saying A produces B dot, so you will be writing R3 in state number 7 at the place $, only. So state number 7 at the place of $, you're going to write R3. Now the 8th state, which is saying A produces small a capital A. So this is R2, means the production number 2. This is production number 2. So you will be using R2 and the row number 8 and the position A and B. R2 and R2. In the 9, this is the production number 2. So you'll be writing a dollar, sorry, at the place of the dollar in the state number 9, or in the table row number 9, you will be writing R2. So in table number 9, in the table row number 9, at the place of the dollar, you will be writing R2. Fine. So now this completes the table. This actually completes the table, which is the CLR1 parsing table. Okay. So this is the CLR1 parsing table. Okay. Now this CLR1 parsing table, if you see the CLR1 parsing table, and if you see these states, some of the states have some commonality. For example, state number 4 and 7, they are same, but the look aheads are different. So state number 4 and state number 7 are same, but the look aheads are different. Similarly, state number 3 and state number 6 are same, but the look aheads are different. So I3 and I6 are same, but the look aheads are different. Similarly, state number 8 and 9, state number 8 and 9 are same, but the look aheads are different. Okay. So these states can be combined. Okay. So these states can be combined, and if you merge these states I4 and I7, you can make it I47, and if you merge I3 and I6, you can say that this state is I36, and if you merge the state 8 and 9, you can say that those states are I89. So let us make these changes at the table also. So we are making a fresh table by looking at this table, which will this actually is the CLR1 parsing table, and now what we are going to make it's a look ahead LR1 table, LALR1 table. So what we have done in the LALR1 table, we have to merge the states. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Action and go to part. Okay. So what we are actually doing that we have to merge the state 3 and 6. 3 and 6. Okay. So you will not be writing the state number 6. You will be only writing the state number 3. Okay. So for writing this, in the action part we had A, B and dollar, and in the go to part we had capital S and capital A. So now 0 state has no change, it remains the same. Okay, 1 state has no change, it will remain the same. Okay, now the 2 state also has no change. You see that 4, 7, 3, 6, 8, 9, these are the affected states. So we are first writing it for 3, from 2 the transitions are S6, S7 and 5. From 3 and 6, so we are actually combining these two states. So we are calling this a state 3, 6. Okay, so you see here we have S3 and here we have S6. So we can write here as S36. Okay, here we have 4 and here we have 7. So we are combining the state number 4 and 7 also. So we will be writing here S47. Okay, so 7 state we will not write. In the place of 7 we are writing 47 state. Similarly, we are not writing the state number 9. We will be writing 8, 9 only. Okay, so we'll first make this table and we'll be converting that to that state. Similarly, see that in the 4th state and the 7th state, R3, R3 and R3. Here we have R3, here we have R3, here we have R3. So no conflict has arisen. We're writing R3 only. Okay. Now in the 5th state has not been combined, so it will remain the same at what it was. Here we have R1. These two states have vanished. And now the 8th, 9th state, you see R2, R2 and R2. R2, R2 in 8th state, and the 9th state we have R2. So R2, R2, R2. No conflict has arisen. Okay. Now, wherever there are the shift operations, we do not have a state 3 here. We have a state 3, 6. So we'll be writing 3, 6 here. We do not have a state 4 here. We have a 4, 7 state. So we'll be writing 4, 7 here. Okay. Now we do not have a state 6 here. We have a 3, 6. So we'll be writing 3, 6 here. We do not have a state 7. We have a 4, 7 state. So we'll be writing 4, 7 here. So what we have done, that we have combined the state, and the number has also been given combinedly. The change in the number are there for the shift operations, but not for the reduction operation. Why it is not for the reduction operation? Because the reduction operation is telling you the production number to use for the reductions. Okay. Now there is one more change here. Here you can see that in the 3 state on A you're going to 8, on 5 state, in the 6 state on capital A you're going to 8. So in the 3, 6 state on capital A you will be going to 8, 9 state. So this is the LALR1 parsing table. This was the CLR1 parsing table, and this is the look ahead LR1 parsing table. It can clearly be observed that the number of state in the CLR1 parsing table is more than the LALR1 parsing table. Okay, so the number of state in the CLR1 parsing table is more than the look ahead LR1 parsing table. But this may be the case only with this example. For the other examples, it may not be the same. It may also be like CLR1 parsing table has the same number of state as the look ahead LR1 parsing table. Obviously, in this example, we are reducing the number of state in the look ahead LR1 parsing table. But it may so happen in some of the examples that the states cannot be combined. So the number of states in the CLR1 parsing table may be same as the look ahead LR1 parsing table. Okay. Now, if given that N1 is representing the number of state in the LR0 parsing table, and N2 is the number of state in the SLR1 parsing table, what is the relation between these two? Obviously, N1 will be equals to N2. Okay. Now, if N3 is the number of state in the CLR1 parsing table for the same grammar, and N4 is the number of state in the look ahead LR1 parsing table. So what is the relation between these two? So this is like N3 may be greater than or equal to N4. Okay, and the best thing is that you can actually observe that there's 1, 2, 3, 4, 5, 6 and 7 states here. The same number of the state used to happen for the same grammar in the LR0 and SLR1 parsing table. Okay, so the relation, if we establish the relation between N1, N2, N3 and N4, it will be that the CLR1 parsing table will have the maximum number of states, which may be either greater than or equal to LR0 or LR for SLR1 or CLR1. Okay, so these N1, N2 and N4 means the number of state in LR0, number of state in SLR1 and number of state in look ahead LR1 parsing table are same, but the number of state in the CLR1 parsing table may be more than all these parsing tables. Okay, thank you.